Imagine a world where computers grow like mushrooms, literally. It sounds like science fiction, but researchers at Ohio State University are turning this into reality, harnessing the power of shiitake mushroom mycelium to create sustainable, biodegradable computing components. In a groundbreaking study, they've engineered living memristors, devices capable of mimicking learning behavior, that could revolutionize how we think about technology. But here's where it gets controversial. Could these fungal-based systems truly replace traditional silicon-based electronics, or are we getting ahead of ourselves? Let's dive in. In their research, published in PLOS 1 https://journals, org/pelosone/article !ID =101371/journal, 0328965. The team outlines a simple, low-cost method to grow and test these mycelium-based memory components. By cultivating shiitake spores in nutrient-rich media, they allowed the mycelium, a branching network of fungal fibers, to colonize petri dishes. Once fully grown, the mycelium was dehydrated into stable, disc-shaped structures, which could be rehydrated to restore conductivity. These fungal discs were then connected to conventional electronics and tested for memristive behavior, a key property for memory and learning in computing systems. And this is the part most people miss. The mycelium's natural structure, hierarchically porous and dynamically conductive, closely mimics the ion-based mechanisms of neurons. When subjected to voltage inputs, the fungal memristors exhibited pinched hysteresis loops, a hallmark of variable resistance states, akin to synaptic plasticity in the brain. At a 5V 10 Hz sine wave, they achieved an impressive 95% memristive accuracy, and even at high frequencies of 5.85 kHz, they retain 90% accuracy. This makes them viable for real-time computing applications, from AI hardware to aerospace electronics. But it's not just about performance. These fungal memristors are fully biodegradable, derived from renewable biomass, and require no clean rooms, toxic chemicals, or rare materials. This raises a thought-provoking question. Could this be the future of eco-friendly technology? Or are we underestimating the challenges of scaling such systems? The researchers also demonstrated their potential as volatile memory, using an Arduino-based testbed to show they could transiently store and recall data, a critical feature for neuromorphic computing. What's truly fascinating is the mycelium's resilience. Shiitake mushrooms can withstand ionizing radiation, making them ideal for aerospace applications where cosmic radiation degrades traditional semiconductors. Plus, their ability to be dehydrated and rehydrated without losing functionality opens up possibilities for shipping, storing, and even transmitting bioelectronic components. Imagine deploying sensors in remote environments that simply decompose harmlessly after use. While this research is still in its early stages, it marks a pivotal shift toward integrating biological organisms into computing. Are we on the brink of a mycelial revolution? Or is this just a niche experiment with limited practical applications? The Ohio State team has shown that computing components don't need to be etched in silicon. They can be grown, dried, and wired into circuits. But the real question is, are we ready to embrace this fungal future? Let us know what you think in the comments. Do you see this as a game changer? Or is it too early to tell?